Alright guys, welcome back. Today we're going to talk about the quadratic formula, something that you guys should be familiar with. You probably know it by song. Maybe I'll sing it in class for you. I'm not going to do it on the video though. And also what a discriminant is. So first things first, the quadratic formula. If you have a standard form of an equation, it has to be in standard form. Y equals ax squared plus bx plus c, so it's the numbers in front. Remember, when you're doing quadratic formula, you're not using the x's at all. The quadratic formula is opposite b plus or minus the square root b squared minus 4ac all over 2a. Okay? And then the discriminant is just the part inside the square root, right? It's taken right out of the square root here. And this tells us a few different things. So, for example, if b squared minus 4ac is equal a positive perfect square, that means that we'll be able to take the square root of it and we're going to get two rational roots. So that means we'll either end up with fractions or nice integer numbers. Okay, if for some reason though b squared minus 4ac is not a perfect square, it's just a positive number, then you just are left with two irrational roots. So that means that we won't be able to take the square root of the number. It'll have to be broken down and stay as a square root. So it's irrational. If b squared minus 4ac is equal to 0, if this whole thing goes to 0, the plus and minus doesn't come into play, and the only thing we have is negative b over 2a, which is just one solution. So you get one rational root. Again, it can either be a fraction or a number. And finally, the last one, if our square root is negative, or our discriminant, a negative anything, it could be perfect square or not a perfect square. I can't spell negative today. Then you have two imaginary roots, because you cannot take the square root of a negative number. Okay, so solve using the quadratic formula. Now, again, this is another way of solving. I, again, prefer completing the square, but this one is more useful when completing the square can get kind of difficult because you're working with fractions and stuff. Try to complete the square first if they're nice numbers, but if not, then go to quadratic formula. So, for instance, we have to rewrite this in standard form. So we get 2x squared plus x minus 5 equals 0. My a is 2, my b, if there's no number in front, is a 1, and my c is a negative 5. So x equals opposite b, so if b is 1, it's going to be minus 1, plus or minus the square root, b squared, 1 squared, minus 4 times 2 times negative 5, all over 2 times 2. Okay, so that is my quadratic formula for number 1. Now we simplify. X equals negative 1 plus or minus. This becomes positive 40 and then a 1. So square root of 41 all over 4. Okay? And again, if you want to give us the real and the irrational part, we can split this apart. And that is it simplified. We can't do anything else with it. We can't break down 41, and we cannot do anything else. So my final answer is, the two answers will be negative 1/4 plus root 41 over 4 and negative 1/4 minus root 41 over 4. And that'll give you, and that is exact. So with these problems, if you're solving with quadratic formula or completing the square, it has to be exact. Alright, now on this one, we want to rewrite the problem. And we have 2x squared. Let's move the 12x over to the right, and then add 5 to the 13. Alright, now, before you use quadratic formula, if you can divide everything by a number, like 2 for instance, simplify it down. We could turn this into x squared, because at the end of the quadratic formula it'll simplify anyways. Now the funny thing is is that this is actually factorable, and in this case normally I would factor it and solve. But for today's purpose, we're going to show you how the quadratic formula works with this one. So x equals opposite -6, so now it becomes a +6, plus or minus the square root of -6 quantity squared, so again that'll become a positive, minus 4 times 1 times 9, all over 2. So when you solve that, you get 6 plus or minus, well, 36 minus 36 is 0, all over 2. Alright, so my only 0 is x equals 3. Because 6 over 2 is 3. The plus or minus does not come into play here. Since the discriminant was 0, we got one rational solution. Finally, let's use this for... let's do this one. Again, if you don't like using a negative coefficient for x squared, you can simplify it by dividing everything by a -1. However, you can use it the way it is also. So, x equals opposite b plus or minus the square root of 2 squared minus 4 times -1 times -2, all over 2 times -1. Alright, so this simplifies to be -2 plus or minus square root of, we get 4, and then these become positive, so -8. So we get a -4 all over -2. Now you guys should remember from, I think, a lesson or two ago, that to simplify -√4, you can pull an I out, and then it becomes √4, which is 2. So plus or minus 2i over -2. So let's simplify each one. Now the nice thing about this is this negative sign for this piece, the 2i piece, doesn't matter because this is a positive and a -2i, so it just switches both signs, which keeps both of them there. But the front part does not. We like to split this apart. So x is equal to -2 over -2 plus or minus 2i over 2. And we get our final answer is 1 plus or minus I. And we're done. So that is the 2 imaginary solutions you get from the quadratic formula on that one. Alright, so for this one just says find the values of c that'll give it 2 real, 2 imaginary, and 1 real. And so let's start with the 1 real, because the 1 real, remember we're using b squared minus 4ac. If this is equal to 0, we get the 1 real. So that'll tell us the value you should start with. Always pick the 0, because then from 0 we can figure out how it goes positive and how it goes negative. So we have b squared, so -3 squared minus 4 times 2 times c, and we want that to equal 0 for our 1 real solution. 9 minus 8c equals 0. -8c equals -9. c is equal to 9/8. So when c is 9/8, that will give me 1 real solution. Okay? Now we have to think about this. Let's look at our initial equation right here. Let's start this. So when c is equal to 9/8, we have 1 real solution. Now you have to think about it the other ways. Let's make c bigger than 9/8. Let's say c is 3. Okay, let's just say c is 3 for example. If you plug 3 in for here, the discriminant becomes 9 minus 24, which is negative. So when c is bigger, which is the other way, than 9/8, the discriminant becomes negative and you get 2 imaginary solutions. Which means that when c is smaller than 9/8, it'll become positive and you get 2 real solutions. Now we can't split up because depending on what c is, you might get rational versus irrational for the real. So we just say it is real. Okay? So I want you guys to try, if you pause, try to figure out what that middle c value is to give you the 0, and then try to figure out which way c should go. Okay, so take a moment to do that. I'm going to set up my discriminant. 4 squared minus 4 times -1 times c equals 0. Always find it equal to 0 first. That gives you your one real solution. 16 plus 4c equals 0. 4c equals negative 16. c is equal to negative 4. So, when c is equal to negative 4, we get one real solution. Let's say c is bigger than that. So let's say c is 0. If c is 0, we get positive. Because if I put a 0 in for c here, you end up with 16, which is a positive number. So if c is bigger than negative 4, we get two real solutions. And that means that if c goes negative, more negative than negative 4, we get our two imaginary solutions. Okay. Alright, so that's quadratic formula and how the discriminant works in the quadratic formula. It basically just tells you what's going to happen. It's the piece under the square root. Alright, tomorrow we're going to work a little bit more with quadratic formula and how to solve different equations.